Now in section 6 of unit 4, we'll be doing the other part of conditional probability in which we're using the and you may recall the and is tied into intersection. All right, let's go on to our examples. Again, you want to include this in your homework log. This will be part of your notebook check. Now, in this first example, it is rather straightforward. We see we have numbers 1 through 15 in our sample space, and we want to select that the number is even. So find the probability of selecting an even number from this. So how many even numbers are there? You go 2, 4, 6, 8, 10, 12, 14. That would be 7. And then out of 15. And you'll type it as a fraction in this case. So this one pretty straightforward. Now, we had one like this in the past, where I made sort of a tree of possibilities. Given a family has 4 children, find the probability of the event. The oldest 3 are girls, given that the oldest is a girl. Now, for this, you'd have to develop some kind of chart. You may have one like this already in your notes. If not, we'll do it again here. Well, as I was writing this out, I had a kind of change of heart because, again, this is conditional. So if the oldest is a girl, it has to be a girl in this first position. So I only wrote the scenario where the first individual is a girl. Now, if it were a boy, you would repeat boys with this, but we're not interested in that. So the oldest 3 is a girl, and again, the oldest is a girl. So here, this oldest is a girl, and the oldest 3 are girls. Now, it doesn't say what the 4th one has to be. Now here, the oldest is a girl, and the oldest 3 are girls. Now, that's the only one that's like this. So out of a total of 2 to the n power, which there are 4 events here, this is going to be 2 to the 4th is 16, as we had mentioned before, that this will then be 2 out of 16, or 1 out of 8, that this would occur. Now for number 3, determine whether the 2 events are independent. Some background, as we mentioned in the flipped classroom lesson, that they are independent if the probability of the events equal each other. That would be the background. So here we're rolling a pair of dice. One is going to be even. So what's the probability of this first die being even? Well, there are 3 sides of a die that are even, 2, 4, 6, out of 6 sides, which is then 1/2. And that the second one is going to be odd. Well, in that other die, it's odd. 1, 3, 5 is 3 out of 6. So that would also be 1/2. Now, the probability of these events are equal. Therefore, we say these events are going to be independent. Now in number 4, and be sure you put your box around it, we're looking at this data which relates to college seniors and what are they motivated by? Money, creativity, a sense of giving to society. We have the female totals, we have male totals, we have the total totals. So fortunately we have 100. So that's going to be our sample space. Now their question that they're asking us is, if one of these students are selected, what is not motivated primarily by creativity? Well, you could add up all of those, or you could look at here. These are the ones motivated by creativity. And what's the total of that? Well, that's 10. So if we have the whole, which is 100, and we subtract those that are not included in this, which would be 10 out of 100, in a sense, we're finding the complement of this, and that would be 90 out of 100. So this is one of the methods we featured in the flipped classroom video lesson, where if there's a lot of data and a little bit of data, we can subtract the little bit of data from the large amount of data and get, in a sense, the complement, which is what they're asking for indirectly here. So reducing that, that would be 9 out of 10. All right. Now in example 5, we have a pet store that has 9 puppies. So our sample space is 9. That is 2 poodles, 2 terriers, and 5 retrievers. Now Rebecca and Aaron, in that order, each select one puppy at random, but with replacement. Find the probability that Rebecca selects a terrier. So let's do Rebecca first. A terrier, there's 2 terriers out of the 9, but then there's going to be replacement. And then Aaron selects a retriever. Well, there are 5 retrievers, but since there was replacement, there's still going to be 9. Now, normally, I'm not sure why I did it this way, because there would be 1 less, but that's without replacement. Here we have with replacement. So this is the setup. And what do you get for a probability? Well, 2 times 5 is 10, and 9 times 9 is 81. And you can't do any cross canceling, so this is the fraction. All right, let's go on. Now for number 6, 2 cards dealt successively without replacement from a standard deck of 52 cards. Find the probability of the event of 2 queens. Well, how many queens are there in a deck? Well, there are 4 queens in a deck out of 52. Now we can simplify that if we'd like already. That's going to be 1 out of 13. But now you've selected, and this is without replacement. So you've selected 1 queen, theoretically. So now there's only 3 left in the deck, and there's only 51 cards. And let me put that 351st up there. Can this be simplified? Well, yes, the rule of 3s. 5 plus 1 is 6, so that's divisible by 3, and That's 1 out of 17. So 1 times 1 is 1, and 13 by 17, according to my calculator, is 221, and that would be the fraction for number 6. All right, in number 7, as we look at it, 2 cards are dealt successively without replacement from a standard 52-card deck. Find the probability of the event the first card is black. Well, there are 26 black cards out of a deck of 52, which is 1/2, simplifying that. Now, and that the second card is a diamond. Now, how many diamonds are there in a deck? Well, there are 13 diamonds. And again, diamonds and blacks, they're different. Diamonds are red. But now we have 1 card less in the deck. Now, we did simplify the 1/2 here. This cannot be simplified. So, when we multiply this, we get 13 out of 102. And that would be our fraction for the probability of this event. Again, if you have a question, you're not sure about something, ask. All right, take a moment as we pause for you to read this, and then we'll see what we get. So the chance of pollution flowing over the launch site is 11%. So what are they looking for? That they will have a launch without pollution flowing would be the complement of this. So just looking at this, what is the complement of 11%? And the answer is 89%. Remember, this is 100% here that we're subtracting 11% from, and that will give us the complement. Again, it's just another technique of doing it. In example 9, again, a rather long paragraph. So take a moment to read it and keep thinking of the complement. That's going to be an important element in solving this in sort of an easy way. So if you thought about it, the chances of an engine not failing, if it's 9% of an engine failing, is going to be 91%. Would you all agree with that? That each engine has a 91% chance of not failing. That's the complement of this. Now, how many engines do we have? Well, we have 4. Now, remember, this is actually 0.91 when we converted it from percentage to a decimal. So put that in your calculator and see what you get. When I put that in my calculator, I got this. So again, the rules for rounding, we go 4 decimal places. We look at the 5th. If the 5th is 4 or less, we drop it and don't do any changes. If it's 5 or more, we add 1 to the 4th decimal place. Here we're just going to keep this as our answer. And again, this is the complement, a good method for solving this type of problem. For example 10, which is a representation of the homework, again, you're going to have different numbers, or in some cases, it may be the same. But here, this is for our classwork participation. The other is your homework grade that is part of your end of term grade. Looking at this, they're saying that individuals toss coins to determine whether they're going to do something or not. Maybe in the past, but not lately. But anyway, they say that chances are it's not really 50-50, but because of defects in the coin or wear, the odds are slightly different. That you're going to get a heads might be this, that you're going to get a tails would be that. And then here, if you toss the coin twice, what's the probability of getting a heads or tails? And it's just the multiplication of these two. And what do you get when you multiply that? Well, 0.2491. By the way, if both were 50-50, that would be 0.5 times 0.5, which would be 0.25. So you see you're rather close. But here they wanted it rounded to 4 decimal places. All right, well, this will wind up lesson 6. We have 2 more to go.